In Lesson 13, we're going to use whole number multiplication to express equivalent measurements. And remember, equivalent sounds like the word equal, where we get EQU. So we know that equivalent means equal measurements. And we're going to use the idea of converting from one factor to another. The first problem we're going to work on is 3 hours equals blank minutes. Step 1 is to identify the factors and labels. Our factors are 3 and then a missing number. And our labels, we're looking for hours to be converted into minutes. Step 2 is we want to rewrite the equation using the given factors label in expanded form. In expanded form means we're going to draw out some of the numbers and separate them. One thing you want to make sure that you're doing is to use parentheses. So the factor that they've given to us is 3 hours, and we're looking for minutes. So I'm going to write 3 hours, and I want to draw out or rewrite that. I have my 3. And I know when something is together like that and there's no other operation in the middle, that means it's multiplication. And here's where my parentheses come in. I have my 3 and I've used that. Now I have hours that I want to do. And I'm just going to label it 1 hour. So we could rewrite 3 hours as 3 times 1 hour. Step 3 is we want to rename, convert, or change the conversion factor into the desired label from the original equation. Our conversion factor is this factor that we're changing. Conversion comes from that thought of convert, which is change. So we're looking at our conversion factor is that factor that we are changing. And we want to change it into the original label for what we would like in our original fraction. So I'm going to change 3 hours, and I'm going to keep that 3 times. But now I'm going to change my conversion factor. I'm going to keep my parentheses, because that shows me that this factor is being converted, and the desired label is minutes. And now I want to ask myself, when I'm converting from hours to minutes, how many minutes are in 1 hour? And knowing what I know about time, I know that there are 60 minutes in 1 hour. So I'm going to put 60 right here. This is still the same equation because I just changed this. I just converted this 1 hour into minutes, and I kept 3 times the same in both problems. Now finally, step 4 is you want to solve. So I'm going to multiply 3 times 60. Since there's a 0 in 60, I'm going to put that at the end of my number. And then I just need to multiply 3 times 6, which is 18. So I have 180. And at this point, I need to remember that I'm also working in minutes. So I need to drop that label down and write in minutes. So my answer is 3 hours equals 180 minutes. Or I could also say that as I converted 3 hours into 180 minutes. And this is a sentence frame that you can use to make sure that you're saying your answer correctly. Let's try another problem following the same steps. This time we're going to do 1 5/100 of a meter equals blank centimeters. The first step is that we want to identify our factors, and we want to identify our labels. Our factors are 1 5/100 and then a blank. And our labels are meters and centimeters. And these are the abbreviations for those two measurements. Step 2 is we want to rewrite the equation using the given factors label. Our given factor here is 1 5/100 of a meter, so I would just drop that down. And then I want to write this in expanded form. So I would take out the number 1 5/100, and I know that anytime two things are next to each other like this without another operation, that is multiplication. And then I would draw my parentheses to show my conversion factor. And I'm writing in meters, and I would have 1 meter. So 1 5/100 of a meter is equal to 1 5/100 times 1 meter. Now I would like to rename, convert, or change the conversion factor into the desired label from the original equation. Here, our conversion factor is 1 meter, and we're going to change that to centimeters from the original problem. So I have my 1 5/100 of a meter here. I keep my value the same, but in my parentheses, I'm going to be changing that meters to centimeters. But I have to ask myself, how many centimeters are in a meter? And I can use this chart down here by looking at 1 meter is equal to 100 centimeters. So in my parentheses, I would draw in my 100 centimeters, which is equal to that 1 meter from our previous equation. And finally, step 4 is we want to solve, and we know that when we are multiplying by powers of 10, in this case 100, I have 2 zeros, so that means I'm going to move my decimal 2 spaces, and my new decimal will be here. So I can say that 1 5/100 of a meter is equal to 105 centimeters. And using my sentence frame, I could say I converted 1 5/100 of a meter into 105 centimeters.